In this video, we're going to discuss some examples of finding probability distribution functions. Suppose a coin is tossed 3 times. Let x be the number of tails in 3 coin tosses. Find the probability function for x. Okay, so to do this, first I'm going to think about my sample space. All right, so first consider my sample space. To consider my sample space, I'm going to use a tree diagram. So I have 3 tosses of a coin, so I can get heads or tails for the first toss. Then I could have gotten a heads or tails for the second toss. Heads or tails. And then for the third toss, I could have gotten heads or tails. Heads or tails. Heads or tails. Heads or tails. Okay, so there are 2 options, then 2 more, then 2 more. So that's 2 times 2 is 4, times another 2 is 8. There's 8 elements in the sample space here. Let's go ahead and list them out. So H, 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 T. I'm just listing off from the tree diagram. So H, T, H, H, T, T. Next one is not H, it's T. So now moving on to the second part of the second branch. So we have T, H, H, T, H, T, 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 H, T, T, T. Okay, we have 8 listed there. Great. All right, let's go ahead. So x is the number of tails. So x is the number of tails. So let's go ahead and think about what x is for each of these possible outcomes. All right, so let's go ahead and think about what x is. So here x would be 0 if you had 3 heads, right? Because x is the number of tails. Here we'd have one tail, 2 tails, 1 tail, 2 tails, 2 tails, and 3 tails. Okay, so now when I'm coming up with my probability distribution function, I'm going to think about all the different possible values of x, of the random variable, and then think about the probability of all those different values. All right, so let's see, the different possible values are 0, 1, or 2, or 3. All right, I could have 0 tails, 1 tail, 2 tail, or 3 tails. Okay, now be careful, don't write 1, 2, 3. Don't write 1 3 times, right? This is just a list of the possible values, so don't repeat yourself when you're writing your list of possible values of x. Okay, all right. So now I just need to think of the probability for each of these values. So now I can look to my sample space and I can calculate these probabilities. The probability that I'm going to have no tail, well, that only happens once out of the 8 elements in the sample space. So 1 out of 8. How often do you get just 1 tail out of the 3 coin tosses? 1, 2, 3. It happens 3 times. 3 out of 8. How often do you get 2 tails? 1, 2, 3. Also 3 out of 8 times. And lastly, how often do you have 3 tails? That's 1 out of 8 times. Right, so there you go. That's your probability distribution function for this random variable, the number of tails in 3 coin tosses. Now you should always double check that the sum of this column equals 1, because that's the criteria for this to be a valid probability distribution function. So let's go ahead and add this up. 6, 7, 8. Yes, this equals 1. Okay, let's do one more example. So a box contains 3 $1 bills. All right, so we have 3 $1 bills. We have 2 $5 bills, 5 $10 bills, and 1 $20 bill. Okay, let x represent the value of a single bill drawn from the box and replaced. Construct the probability distribution function for x. go ahead and start drawing this out. So X is the value of a bill. So the bills that are in the box are either 1, 5, 10, or 20. Okay, then now we just need to figure out the probability associated with each of these different bills. All right, so starting with 1, what's the probability that we're going to get a 1 if we draw into the box? Well, let's see, there's three of the bills are 1. Okay, how many bills are there total in the box? I have to add this up. 3 plus 2, so 3 plus 2 is 5, plus another 5, and then plus 1, that's 11. Okay, so 3 out of the 11 bills in the box are $1 bills. All right, how many are $5 bills? Well, 2 out of the 11. So the probability of getting a 5 would then be 2 out of 11. How many are $5 bills, or $10 bills? 5 of them are $10 bills. Oh, 5 out of 11 bills. Okay, and then how many are $20 bills? 1 out of 11. All right, so there you go. That's your probability distribution function. Again, you should always sum up the probability to make sure it adds up to 1. If it does, then that's a valid probability distribution function, and you have your answer.